Hello, welcome to, as you can see, this is Completing the Square Part 2. You should already have a firm grasp on Part 1 of this idea. So if you don't yet, I would make sure that you have Part 1 down before we start this video. So what I'm going to do is I'm going to kind of walk you through some of the examples on the note sheet to give you some guidance on how we can use this Completing the Square for more types of quadratic expressions. Okay. So it says, consider a square with side lengths of x inches. The function a of x equals 4x squared gives the area of 4 of these squares. Model this expression with the diagram below. So we started part 1 the same way, but we had only one of these squares. Now we're just doing 4 of them. So you can just do 4 separate squares. All right, of course, they should all be the same size. Mine are a little bit off, but we have x squared 4 different times. So this is a model for the expression for x squared. Okay? So these expressions that we see are going to have a called our a term, right? Or it's the coefficient. In this case, it's the 4. That's the coefficient on our x squared. Okay? So we're going to have cases where it's not just starting with x squared. It might start with 2x squared, 3x squared, and so on. So number 2, it says write 2 equivalent equations to show the area of the diagrams below. If you think back to part 1, we talked about the trinomial and the square of binomials. So we're going to do the same thing here. So let's start with the trinomial. Remember, we found the trinomial by counting our different squares. So we're going to do the same thing here. So here I see I have x squared and x squared, which means we have 2x squared. And then my x bars, I have 1, 2, 3x right here, 4, 5, 6x right here, and of course there's going to be 6 more over here. So it's going to be 2x squared plus 12x. And then for my little squares, I see 9 right here, and 9 more right there. That is going to be plus 18. So that is one way to show the area of this diagram. Okay? Now the other way is the square of binomials. Okay. So the square of binomials. All right, and well, let's start. We have 2 of these squares, and if we look at our side length, just like we did in part 1, our side length for each square is x, and then we have plus 3. So it is 2 times x plus 3 squared, because there's 2 of them. So those are the 2 equations we're looking for in part 2 here. All right. Notice we have a coefficient that's not 1 in front of our trinomial, and that same one shows up in the square of binomials. Number 3, same idea, but I just give you words instead of the diagram. What equations for the area could you write for 2 squares that have both dimensions increased by 1 inch in comparison to the basic block? Write the area equations in 2 equivalent forms. Verify your algebra using a diagram. I'm going to start with the diagrams. So we have our basic block, and then it is increased by 1 inch. So I'm going to draw 1 and 1. And there are 2 of these, so there's another one over here. 1 and 1. And I need to complete the square, so I need 1 extra dot on each of those. So if that's my diagram, my 2 equations would be, I have 2x squareds. My x's, I have 2 in each diagram, so that's going to be 4 total x's plus 2 total dots. There's my trinomial. My square of binomials, there are 2 of them. Both squares have a side length of x plus 1 squared. Take a second and try number 4 on your own. Okay, so try number 4. The answers are posted on Canvas. So if you get number 4 and want to check your work, you can pull up Canvas and see what you get for number 4. Moving on to number 5. All right, this is where we have a piece of information missing. So complete each expression so that it represents a perfect square. Then write 2 equivalent equations for the area. Verify your work using a diagram. Okay, so we are missing our c term. All right, we're missing that constant at the end. So for A, let's think about our diagrams. They have 2x squared, so I would have 2 of my squares. And then in total, I have 8 x's. All right, so if I have 8 x's in total, how many am I going to have in each of my diagrams? I'm going to have 4, right? So there's 4 in each. And then if I'm splitting them on both sides, right, in this first one I'll have 2 on the right side and 2 on the bottom. In my second one I'll have 2 on the right side, 2 on the bottom. Which shows me that I need, to complete each square, I need 4 dots, so I'm going to add 8 total to complete this perfect square. Okay. So I've got the trinomial now, 2x squared plus 8x plus 8. And from my diagrams, I can see the square of binomials. Our side length is x plus 2, so it would be 2 times x plus 2 squared. And those are our 2 equations. Looking at 5b, let's do the same thing. So I have, in this case, I have 3x squared. So I'm going to have 3 separate diagrams here. And now I have 24 x's. So if I have 24 x's and I'm splitting them between 3 squares, how many will I have for each square? I should have 8 in each. And each of those 8 gets split up 4 on each side. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And 4. So now I can tell that I'm going to need 16 in each diagram to complete the square. And I know 3 times 16 is 48. So I have to add 48 there. And then I need to write my 2 equations. So we have 3x squared plus 24x plus 48. And then my square of binomials, there are 3 squares. My side length for each one is x plus 4 squared. Okay. All right, flip your paper over. So 5 was just asking us to complete the perfect square. 6 is giving us some extra information. Right? It says find out an equivalent expression for a of x equals 2x squared plus 12x plus 13 using a diagram. Okay. So we've got our diagram, but somehow we need to come up with an equivalent expression. And since I see that this is a trinomial, I know my equivalent expression should be a square of binomials. Okay, so I'm trying to find the square of binomials here. So what I'm going to do is I'm going to try to arrange my blocks into perfect squares. So I have 2x squared, so I use those. And then I should have, from my equation, that there are 12 x's. So if I have 12 x's, that means that I have 6 on each diagram and 3 on each side. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so far that's pretty similar. And then I have 13 of these little blocks. So 13 of those little blocks means that I can fill in 9 here, but I only have 1, 2, 3, 4, 5, 6, 7, 8, 9. I only have 4 left here. Okay, what does that mean? Well, if I write my expression, I have all of this. All right, I can write it in my square of binomials, so that's x plus 3 squared. However, I'm missing 5. All right, I'm 5 over. I'm 5 too big with this expression, so at the end, I need to subtract 5 because I was missing those 5. So that is an equivalent expression for the trinomial. Okay. Let's do another one like that because that minus 5 might be throwing some of us off. So number 7, here's another scrambled diagram, right? 2 equivalent equations. Okay, so first of all, we got to get the trinomial. So my trinomial, I have 3x squareds. I have 1, 2, 3, 4, 5, 6 x's. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 x's. So there's my trinomial. Now let's think about how we're going to split that up. Okay, so if we think about the diagram here, we've got 3 different x squareds, and I only have 6 x's, so that means I'm going to have 1 on each. 1 on each, which means I only have 1 dot going to each diagram, so I have 7 extra, or 7 left over. So if I now write it in my square of binomials, I have 3 squares that have side length x plus 1, but that doesn't cover all of these blocks because I still have those 7 extra blocks. Okay. So there's my 2 equations for number 7. All right. Number 8, determine whether each expression below is a perfect square and why the expression is or is not a perfect square. If it is not a perfect square, find the perfect square that seems closest to the given expression and show how the perfect square can be adjusted to be equivalent to the given expression. That's a lot of words. For number 8, here's what we're doing. We're doing the same thing we did in 6 and 7, we just don't have the blocks. Okay, so we're taking a quadratic expression and writing it in this other form. In this case, we're going from trinomial to a square of binomials. Okay? So I'm going to do 2 of them with you, and then I'll leave the other 4 for you to do. So let's look at A and B. So starting with A, I have x squared plus 6x plus 13. Okay? So if I'm going to write that into, I'm going to determine if it's a perfect square, I'm going to draw out my diagram. All right? I have x squared, I have 6 x's, so I'm going to put 3 on each side. And then I know that to complete the square, I have 9 little dots right there. So I'm still missing, or I have 4 left over. Okay, I'm 4 above what I need. So if I go to my square of binomials, my side length is x, I have plus 3. But that doesn't capture the whole expression because I still have 4 dots left over, so I need to add plus 4 there. Okay, so that would be my equivalent expression for A. Okay. In B, I have a negative 8, but remember the negative still works the same way. So if I think about B, I'm still going to use my diagram. Then I'm going to have 4 on each side. And I need 16 there, so I have what I need with those plus 16. So this is a perfect square, so we can write it, we know it's going to be x minus 4 squared. And let's do one more that's not a perfect square. So looking at C, x squared minus 10x minus 3. So we've got x squared. We're going to have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Now, I know I need, that's 5 by 5, so I'm going to need 25 there, but I'm already at negative 3. All right, so I'm really 25 more short than negative 3. Right, so I really am 25 short with the area here, so when we write it, we'll have x minus 5 squared, but I don't have those 25 dots, so I'm going to say minus 25, have the minus 3 from there, and minus 25 minus 3, I can combine that to say minus 28. Okay. All right. That was a summary of some of it. So try D, E, and F on your own. All right. The answers are in Canvas. Teachers can definitely help you as well. Number 9, you can save. We're going to do this. We might get to it today. We might get to it Friday in class. Okay. So thanks for watching. If you need to go back and rewatch part of it, definitely do so, and work with those people around you to help you get through completing the square part 2.